C1 Coordinate Geometry Exam Question May 2007, Part C. In this question, we've been given the line L1 and L2. So if we look at L1, if we produce a quick sketch of that, it's already in the form y equals mx plus c. So our y-intercept, where it crosses the y-axis, is going to be the plus c on the end. So here it's plus 2. So the line L1, which I've got here in red, crosses the y-axis at 2. So that's the y-intercept. The gradient is 3, so that's why it's uphill. It's a positive gradient. The line L2, we've not been given that in the form y equals mx plus c, but for part A, we rearranged it to get it into that form, and this is what we were left with. So this is our c, which is our y-intercept. So the line L2, which I've got here in green, crosses the y-axis at 4. So that's the y-intercept. And our gradient is minus 3 over 2, which is negative, so that's why the line L2 is downhill. For part B, we worked out the coordinates of P, which was the point of intersection of the lines L1 and L2. So if we look on here, the line L1 in red and L2 cross, so they intersect at the point P, which we worked out in part B was 4 over 9, 10 over 3. So part C is asking us to find the area of triangle ABP. So if we look here, the lines L1 and L2, it tells us it crosses the line y equals 1 at the points A and B respectively. So L1 crosses the line y equals 1 at the point A. So we've got L1 here in red, and I've got y equals 1 in pink. So they cross at the point A. And then I've got the line L2 and the line y equals 1 cross at B. So L2 I've got in green, it crosses y equals 1, which I've got in pink, at the point B. So I've got my points A, P and B, and that forms a triangle. So I need to work out the coordinates of point A and of point B. So to do that, I need to substitute y equals 1 into each of these two equations. So if we look at L1 first, point A, we know the y coordinate is going to be 1 because it lies on the line y equals 1. So we need to work out the x coordinate. So we know y equals 1. So where we've got y equals 3x plus 2. So we know y is equal to 1, and we need to work out what x is equal to. So I need to rearrange this. So I'm going to take the 2 over. Minus 1 is equal to 3x, and then divide by 3. So I've got minus the third is equal to x. So point A is minus the third and 1. To work out point B, we do the same thing. This time, we know that the y coordinate of point B is 1 because we've got the line y equals 1, so we know the y coordinate is going to be 1. So we need to work out the x coordinate. So I'm going to substitute y equals 1 into the equation for the line L2. So we've got 3x plus 2y minus 8 is equal to 0. So instead of y, I'm going to put in 1. So I've got 2 multiplied by 1. So that's just 2 minus 8 is equal to 0. Now I just need to rearrange that to get x. So I've got 3x plus 2 minus 8 will give me minus 6 is equal to 0. And if I rearrange that, I can take the 6 to the other side and then divide by 3 to get 2. So point B is 2, 1. So now I've got my points A and B, I need to find the area of the triangle APB. This is my point A, P and B. So I've just drawn this out again. So to work out the area of a triangle, I need to remember the formula, which is half times base times height. So I need to work out my base and my height. So if I look at the base here, I'm going from minus a third all the way to 2. So my base is going to be 2 and a third. And then if I look at my height, I'm going from 1 up to 10 over 3. So I can do that here. I can do 10 over 3 minus 1. So 10 over 3 is the same as 3 and a third, minus 1. And then I can do 3 minus 1, which is 2. And then I've got that third as well. So my height's going to also be 2 and a third. So I've got my base, I've got my height. So now I need to put it into this formula here. So I'm just going to change the 2 over 3, 2 and a third to 7 over 3. So I've got a half times the base, which is 7 over 3, times the height, which is also 7 over 3. And then I need to multiply those together. So I've got 7 times 1, which is 49. And then I've got 3 times 2, which is 18. So this is the area for the triangle APB.